Aviation is one of the most difficult sectors to decarbonize. While electric cars have rapidly entered mainstream transportation, airplanes face a much harder challenge. Batteries remain too heavy to power long-distance flights, and jet engines still dominate modern aviation because of their unmatched energy density. But engineers are now exploring a transitional approach that could significantly reduce emissions without completely replacing existing propulsion systems. A hybrid electric aviation system developed by RTX aims to combine conventional turboprop engines with powerful electric motors to create a more efficient aircraft propulsion architecture. At the core of this system is a hybrid configuration that pairs a traditional turboprop engine with a 1 megawatt electric motor and a battery system capable of storing roughly 200 kilowatt hours of energy. These components work together to drive the aircraft's propeller while sharing the workload across different phases of flight. During takeoff and climb, which are the most energy-intensive parts of a flight, the electric motor can provide additional power alongside the turboprop engine. This assistance allows the engine to operate more efficiently and reduces the total fuel required to lift the aircraft into the air. Once the aircraft reaches cruising altitude, the conventional engine can take over most of the propulsion duties while the electric system reduces its workload. In certain scenarios, the electric motor can even help smooth power demand across the system, improving overall efficiency during the flight. To test this concept in real-world conditions, the hybrid propulsion system is being integrated into a modified de Havilland Dash 8 aircraft. This experimental platform will allow engineers to evaluate how the engine, motor, batteries, and power electronics operate together under actual flight conditions. Early projections suggest that hybrid electric propulsion could improve fuel efficiency by roughly 30% compared with conventional regional turboprop aircraft. That improvement may not completely eliminate aviation emissions, but it represents a meaningful step toward more sustainable air travel. Hybrid propulsion also offers an important advantage over fully electric aircraft because it does not rely entirely on battery energy density. Instead, it uses electric power strategically, where it provides the greatest efficiency benefits while still leveraging the reliability and range of conventional engines. If successful, this approach could influence the next generation of regional aircraft, which typically carry between 30 and 100 passengers on short-distance routes. These flights represent a significant portion of global aviation activity, making them an ideal target for early hybrid technologies. The broader significance of projects like this lies in their role as stepping stones toward fully sustainable aviation. Hybrid propulsion allows engineers to develop electric power systems, high-voltage components, and advanced energy management technologies that may eventually enable fully electric or hydrogen-powered aircraft in the future. In that sense, this hybrid aviation system represents more than a single experimental engine. It represents a transitional architecture that bridges the gap between traditional jet propulsion and the next era of cleaner flight. If you want serious, data-driven breakdowns of the engineering technologies shaping the future of transportation and aerospace, subscribe now and turn on notifications, because the next revolution in aviation may not arrive all at once. It may emerge through hybrid systems that combine the best of both worlds.